In this first section of the course, we're going to see how science works to learn about the universe. The scientific method not only applies to understanding black holes and galaxies and the Big Bang and exoplanets, but also to understanding everything in nature, including evolution and all our other scientific theories. So the tools we're going to talk about are quite general across the field of science. Science starts with evidence of the natural world, and physical or regular laws that can explain the behavior in the natural world. Now, astronomy is not like most sciences because the evidence we have is often remote and comes to us in the form of electromagnetic radiation. Astronomy is not a lab science, so we cannot control the experiment of the universe. But the information we gather is extremely powerful and diverse, and has allowed us to learn situations that are extraordinary, such as the event horizon of a black hole, or the atmosphere of a distant Earth-like planet 100 light-years from the Earth, or the earliest phases of the expanding universe, when temperatures were extremely high. The evidence of science is combined with logic and the idea of building theories that explain diverse sets of data. Science is a contingent enterprise, and so scientific theories are always on their mettle to be proven against new data sets, and are always at risk of being disproven if data does not fit the theory. This has happened in astronomy a number of times. And we'll talk about the history of astronomy, which includes some of these progressions where theories have been discarded and replaced by better theories. Mathematics underlies astronomy and all the physical sciences because it's emerged over the last century that the universe is governed by physical laws that have beautiful mathematical underpinnings. The reason for this is not completely understood, but the explanatory power of these mathematical theories is quite extraordinary. The theory of gravity is perhaps the most famous example of this. We will look at the nature of the evidence in astronomy and of the theories that have come to be the most profound to explain our place in the universe. Then we will look at the history of astronomy. Astronomy is perhaps the most dynamic science with discoveries every week, but it's also the oldest science. Astronomy starts with observations of the night sky, millennia before the telescope was invented. Humans were looking at the motions of the stars, the planets, the sun, and the moon, and trying to understand what was going on. Where were these objects? What were they made of? We'll look at ancient astronomy, cultures around the world observing the same phenomena and trying to make sense of them, without telescopes and really without any mathematical underpinnings, but just looking at the regularity of the patterns in the sky. Regularity that you can see if you go out for a year and look at the phenomena of the night sky. These ancient civilizations were not approaching the problem in a purely scientific way. That innovation came from the ancient Greeks. About 2,500 years ago, with Pythagoras and the ideas of mathematics, and with Aristotle and the ideas of logic, we have the basic toolkit for doing science. And science still depends on that same basic toolkit. As we look at the history of astronomy, we'll see that these powerful ideas gradually gave us a more and more broad view of the universe, explaining not just the phenomena of the night sky, but the phenomena revealed by the telescope after it was invented in the early 17th century. And then we'll look at the Copernican revolution, perhaps the most profound change in the history of ideas in the history of humanity, where, from a position where we thought ourselves the center of the universe and the pinnacle of creation, we realized that the Earth was in motion around the Sun and was just a planet amongst other rocky bodies in the solar system and beyond, and that the Sun was just one amongst many stars in the Milky Way galaxy and eventually among galaxies beyond. This profound shift in our views, called the Copernican revolution, continues because in the modern era it emerges that the totality of space-time we see, the observable universe, may not be the only universe. Perhaps the last step in the Copernican revolution would be the demonstration that the biology of this planet, life on Earth, is not unique to this planet and that life exists elsewhere in the universe. We can anticipate that astronomers will make this discovery perhaps in the next decade. This first section will try to summarize the principles that govern science, not just astronomy, but all fields of science as they explore the natural world.